Whoa, there we go. Hello, welcome back to part 2 of animating with the WS2812b LEDs. In this video we're going to start to look at some animations that you could do with the LEDs using a microchip PIC18F26k22. Now we're using a PIC programmer in this video, and if you want to look at the previous video you can see exactly how we put it all together. Remember, all the code that you see on the screen is available in the description down below. Okay, let's get started. So in our code we created this function here, LED data, and this basically contains all the assembly language needed to drive those LEDs. In our function here, so this is our main program, just this part here, it's not very big. We're running our oscillator at 64 megahertz. So we're basically, in this bit of code here, we're just flashing our LED, which is this LED on the board here. So high, low, and then every time we go through that loop, we're then sending some data to our RGB strip of LEDs, and we're saying send out, we're saying send out. At the moment it's red, so this function is green, red and blue, so we're sending 0, 255 and 0. So if we wanted to change that LED to yellow, let's put a 255 in the green and we'll have green and red both at 255. So let's send that down to the electronics. So here we are, the PIC kit is responding, programmed. Okay, and there we are, we have a yellow LED, and that's because we now have 255 on red and 255 on green. Now how about if we wanted to light up more than one LED? So we want to light up 3 LEDs. Well, what we need to do is send out 3 sets of data. So if I copy that and then paste it again, and the first one we're going to send as red, so I'm going to delete the green. Second one we can send as green, I'll delete the red. And the third one I'll send as blue. So I shall add in 255 on blue. Let's compile this and send it down to the chip. And the chip is now programming. And there we are, we've got a red, we've got a green, and we've got a blue. You can't see the green very clearly there, but it's definitely green. So in this script, S08b, at the top we're declaring 3 separate arrays, LED red, LED green and LED blue, and each one has a count of 500 bytes. In our main function, I'm calling a function called flash onboard LEDs, and that is here, and it will basically flash this onboard LED, output high, output low, with a 100 millisecond delay in between both of them. We're then calling a function called fill LEDs. This function here creates a loop, a for loop. It starts at 0 and it ends at 29, and it enters the value of 255 into each instance of the array of LED red, 0 into LED green and 0 into LED blue. I'm then sending this function send LEDs. This function creates a for loop. It starts at 0 and it ends at 29, and it calls our LED data assembly language function, which is at the bottom here, and it sends each instance of I at between 0 and 29. So LED green, LED red and LED blue. So when we compile this script, and I'll run it now, compile, sending it down to the processor. There we are. We have 30 LEDs, all at red. If we wanted to change those to yellow, let's add a 255 in the green. compile that down, send it down to the LED. They're all yellow. So what if we wanted to fill half of it one colour and half of it another colour? Well, we could separate this function here. So I'm going to double that function, and I'm going to say 0 maybe to 16, and 16 to 30. And instead of saying green, we'll do that. So 0 to 16 should be red, and 16 to 30 should be green. Let's compile that and send it down. Sending down, there we are. So we have half of our LEDs are red and half of our LEDs are green. Let's change those to blue. Should be compiled. There we are, red and blue. It looks like a police car. So you can see how simple it is to write a variable into the array of the LED, and then we can send all of the LEDs down as we need to. And this will be very useful later on, because for our animated flame we'll be sending down 100 RGB LEDs all at once. So having an array is a very simple way of being able to arrange the LEDs just as you need them. So in the last function we showed how we could fill an array with RGB values and then send it as a block of data to the LEDs. But that was static information. Those values aren't changing, those colours aren't changing. In this script, S09A, what we're trying to do is we want to walk an LED through the array. So in our main function, we're calling a function, a subroutine called raise LEDs. Now, the way this works is that the first part of it, this part here, we've got a counter. That counter is called LED delay up. Once that counter gets to 10, we reset it to 0. That means that once it's reset to 0, this part of the function can work. Basically, this part of the function is only being called once every 10 times that raise LEDs is being called. It means that we can slow down our processing, slow down our animation slightly. So what are we doing when we call this function? Well, once this part of the function activates, we're calling another function called LEDs off. So in this function here, LEDs off, we are creating a for loop. Now this for loop is counting from 0 to 29, and each time I is from 0 to 29, we're then setting the red, the green and the blue value of I to 0. It basically means that we're clearing all the LEDs to 0. We're then incrementing our LED index. Now our LED index is the current index of the array that we are working in. So here, if the LED index is greater than 30, reset it back to 0, which basically means that every time we call this function, we are just counting from index 0 to index 30 along the LEDs, and then we're setting the LED to a specific colour here. Here, LED blue, LED index is 255. So theoretically, that means that we should have a blue LED walking along our LEDs. So let's run it and see how that works. We compile it, send it down to the LEDs. Okay, there we go. That's pretty fast. So you can see that in raise LEDs, this is the LED display divider time. if I change that value, let's maybe go to 50 instead and send that down, will it speed it up or will it slow it down? Well, it will slow it down, it should do. There we are, because that function here is only being called every 50 times instead of every 10 times. So what happens if we put a value in it like 5? How fast will that be? Let's send it down. Whoa, that's pretty fast. That's probably too fast. So we'll set a value of around about 20. There we go. So we've got a value of 20. Although it's pretty harsh, it's just going on and then off. What it would be nice to do is to be able to create a tail. And our tail is where you set an LED to be able to go on, and then that LED will slowly go off over time. So it's like creating like a tail of a comet. So we can do that. What we need to do is have another function which can turn the LEDs down at the same time as our raise LEDs function is turning them up. So whilst we've got our nice blue walking LED, we want to be able to give it a tail. So I've added a couple of functions in S09b. In S09b, we are looking at the raise LEDs function. But what I'm doing is I'm removing here, I'm commenting out the LEDs off. We don't want to turn off the LEDs here. We want to increment and make them go up, but we don't want to turn them off here. So how are we going to turn those LEDs down? In the while function here, I've added a function called lower LEDs. We're creating a for loop, and I is going from 0 to 29, and then for example here LED blue I, if it's greater than 0 then we're going to take it down. So every time this function is run, it will only run this part every 2 times that this function's run, which is a lot faster than the speed that this one's running. This is running every 20 times, this is running every 2 times. So I would expect this to do a lot more work than this one here. Okay, so let's run this and see if it works. Let's press the run button, send it down to the chip. Oh, look at that. There we go, we've got a nice tail. So how can we make that tail shorter? Well, let's change this value of 2 in the lower LEDs to 1. Let's see how that runs. Programming. There we go, we've got a shorter tail now because that section of code is running faster. So it will turn those LEDs down quicker. And let's try and make the actual speed of our comet go quicker. Let's stick it at 10 and let's see how this runs. There we go. So that's a value of 10 and a value of 1. So that shows you how you can make a basic tail by having one function that raises the LEDs and another function that lowers the LEDs. So I'm going to revert all our numbers back to our numbers back to the original numbers that we put in, 20 and 2. So let's make our animation a little bit more interesting. We've got a blue comet going from right to left at the moment with a nice tail. How about we have a red comet going the opposite direction? Let's download S10A and have a look. So there we go. What do you think of that? That looks quite nice. Nice reds and blues swishing across. So how are we making this one? Well, let's have a look down at the bottom of our script. So in our while function, we've still got lower LEDs and we've got raise LEDs. Now if we go to raise LEDs, you can see that we've got all our interval timings as we have had previously. And this is exactly the same as it was previous, apart from where we've got LED blue, index is 255, counting from 0 to 30. We're also adding LED red, counting from 30 to 0, as 255. So you've got blues going in one direction and you've got reds going in the other direction. So how about going down? Let's look at lower LEDs. Lower LEDs, if the blues are more than 0, then take them down. If the reds are more than zeros, take them down. So all the LEDs are being reduced at the same time. So the only thing really that's driving it in the directions is here, the LED blues in one direction and the LED reds in another direction. Now have a look at this one. So I'm going to download script 17A. So 17A is one of my favourite ones. This, as it comes up, is downloading, and here we go. This is my Knight Rider effect. If you're from the 80s or from the 70s or whenever Knight Rider was, it's one of my favourite TV programs. But yes, this is my Knight Rider effect, and this is done by having a direction switch. So how does this work? Okay, so let's have a look at our main function here. We are calling raise LEDs and lower all LEDs fast. So what do these ones do? Raise LEDs. Well, it's the same as what we had previously. This is the section that gets processed every 30 times through the loop. We've got a variable called LED index. It's the LED that we're currently working on in the array. So if the LED index is greater than 30, then LED direction is 0. So 0 is backwards, going this way. If the LED index is here, index is 0, then we want the LED direction to be 1, to go this way. So every time through the loop, if the LED direction is 0, going this way, we want the LED index to go down. If the LED direction is 1, we want the LED index to go up. And then we set the LED index of the LED array of 255. In our function of lower all LEDs fast, we are calling the function every 15 times through the loop. So every time this is called, we're processing this part every 15 times. Once every 15 times this function's called. And we are saying for I equals 0 to 31, all the LEDs in our array, we're then repeating this function 6 times. We're repeating this function 6 times. So if LED red is high, lower it, and then if LED red is high, lower it. So it's a way of increasing our lowering speed. So previously we didn't have anything like this, but this time we are now trying to reduce things faster by checking if it's high and lowering it. And then we are sending our LEDs out. So the direction control, this is all we're using for direction control. So is if the LED index is going high, and we get to 30, then LED direction is 0, and then we go LED back down again. And if the LED direction is 1, then we go back up this way again. Just a little bit of simple mathematics to give a bit of direction control. In our next video, we're going to start sending blocks of RGB data down to our interrupt routine of what we did in the last video. Now have a look at this. This is the compiler that I use to create my Windows applications. And in this application, I have a small selection grid, and this grid I can hit the P button and I can generate a flame. And down here is the RGB values that will be sent to my electronics. Now if I start the LEDs actually receiving the data, you'll see that a lot of the colours are very similar to what you're seeing here, and that's because they're representing the colours as they come out. So as I move the grid around, we can select how much of the data is actually sent out. If we want to scale the grid, we can do. We can literally just do a bit of corner pinning around an animation, and then we can just take the our selector and basically send that data out. And how good does that look on the LEDs from the array here? No, it's not just doing from predetermined animations. We could also do something from say for example a web page or YouTube or something. So let's go into a desktop mode, and you can see here now that I am basically, we're reading in from the desktop, and I can actually, if I take my grid mode, and there we are, our colours are now changing to, if I move that over there, no, let's move that down, move that up. So I've moved this grid around, and you can see that the colours are changing dependent on what we're actually looking at, and that's actually being sent straight out to the LEDs. So I'm going to introduce all of this in the next video, and that will be part 3. So I hope you enjoy this video. If you've got any comments or want to ask any questions, then please feel free to write them down in the comments below. If you've liked the video, then press the like button, and if you haven't subscribed, then feel free to subscribe to the series. Don't forget that all the code that you've seen is down in the description down below. And if there's anything else anybody needs, then just feel free to ask in the comments. So until part 3, thank you very much for watching. Bye-bye.